Okay, part 4, lecture 6. We're going to talk about what happens when there are changes in the economy, what happens to the money market equilibrium. We're going to consider 3 experiments: increase in GDP, increase in money supply, and increase in price level. Make sure you have your color pens to follow this. So let's first start with the effect of an increase in GNP on the interest rate. When GNP increases, Y increases, we know that money demand is going to shift to the right. So all demand for real money balances is going to shift to the right. And so the new one is in red. And money supply is not going to be affected because we didn't say it would be affected, and it's exogenous. So new equilibrium is going to be where money supply intersects the new money demand, and therefore interest rate is going to increase. The intuition for this: when output increases, there's more goods to buy. So individuals for the given interest rate want to hold more cash because they want to buy. And so they're going to sell assets and push the prices of those assets down, which increases the returns on those assets and therefore increases the interest rate. Or they would want to borrow. And as they want to borrow, they also bid up the interest rate, as we discussed on the previous slide. And new interest rate is higher than the original one. What if money supply increases? I think the slide's animated. So we have an initial equilibrium in point 1. And so we have initial money supply, M1, divided by the price level. And we have money demand, L of I and Y. And suppose real money supply increases because nominal money supply increases and price level doesn't change in the short run. So the new money supply is M2 divided by P. And now we see that we have an excess supply of money. And so as people want to get rid of the money, they either buy the assets, bidding the price of the assets up and therefore interest rate down, or, or they're going to want to lend money and also bid the interest rate down. And therefore equilibrium is going to move from point 1 to point 2. Finally, a third experiment. Suppose for some reason the price level increases. So initially we're in point 1, money supply doesn't change, money demand doesn't change, but now the price level increases. As price level increases, M over P has to go down because P is in the denominator. Why doesn't demand for real balances change? Because the demand for real balances is L, that's a function of I and Y, and it has to be equal to M1 M over P, but it by itself does not depend on the price level. So when the price level changes, people still want the same amount of real money balances. And other things being equal, they're going to want to hold proportionally just as much money as the prices went up. But are other things being equal? No, other things are not being equal because money supply hasn't changed to accommodate the increased demand for money from people as the prices went up. And because money supply didn't change, the new equilibrium now is going to be at the higher interest rate because effectively the supply of real money has gone down when supply of nominal money remained the same and prices went up. So the interest rate is now going to be at 0.2 at the higher interest rate. Now let's do something that we're going to be doing quite frequently in this class and plot the timelines for all the variables we just discussed. So we want to, the experiment was the price level was going up. So if we plot real money balances, because money supply didn't change, we see that at the time of the shock, real money balances jumped down instantaneously and remained at the lower level for the rest of the experiment. What happened to interest rate? At the time of the shock, interest rate doesn't jump because it takes time for people to bid it up as they adjust to the new real supply of money. So slowly, as we move to the new equilibrium, that's why there are many little arrows here, interest rate is going to increase until it reaches I2, and then it stays there forever. Okay? So some variables can jump, some variables can't. So the price level jumps here exogenously. So we draw it as a jump, but the interest rate does not instantaneously move because it takes some time for the asset markets to adjust to the new equilibrium. It might be a few seconds, it might be a few hours, it might be a few days, but it's not instantaneous. Okay, so get yourself familiar, please, with this kind of time charts because we're going to use them a lot. Okay, and moving on. There are two types of the analysis that we're going to do in this class. The short-run analysis, in which the price level and the real output are given, and the long-run analysis, in which the price level is perfectly flexible. So it's going to adjust to the long-run equilibrium. And it's going to adjust so that we always have full employment. I'm saying here immediately, but it just means when we move from one long-run equilibrium to another, we're just going to assume full employment at all times. So now what we're going to do is combine the money market equilibrium that we just got ourselves familiar with the exchange market, foreign exchange market equilibrium that we discussed a week ago. So to do that, what we're going to do is take the money market equilibrium chart and flip it on its side. So the interest rate axis that was vertical before is now horizontal. And see, rate of return in dollar terms is the interest rate. And here we have the supply of real money balances. And then we just glue this sideways money market chart to the bottom of the exchange rate equilibrium chart that we talked about a week ago. So let's think about equilibrium in the short run. Output and the price level are given. Money supply is exogenous. Okay, so MS over P is given. Okay, this line is given. This line is the demand for real money balances as a function of output, which is given. So the variable that adjusts first is the interest rate, which is here denoted as R rather than I. It's the same thing. Okay? As the interest rate is given, that helps us understand the equilibrium in the foreign exchange market because expected return on euro deposits is given by the expectations of the exchange rate, pretty much, in the foreign interest rate. And the return on dollar deposits is now determined by the money market. So it's R1. And so the equilibrium here has to be E1. So the thing to remember about this double chart is that money market clears first and determines interest rate. And then foreign exchange market clears given that interest rate. And that's what determines the exchange rate. So we're moving here counterclockwise from money supply of real money balances, to make it equal to demand for real money balances, gives us the interest rate. The interest rate on dollar has to be equal to the interest rate on we are going to earn if we invest in the foreign deposits. And where this is equal, the uncovered interest parity holds. That's what's going to give us the exchange rate. Okay, so nothing complicated. There's just two graphs glued together. And make sure you remember that we always go in this direction. Okay. And this chart is a reminder of that we have a money market that determines interest rate in two countries, and then there is a foreign exchange market that determines the exchange rate. And it's the central bank that provides the money supply in the US and in Europe that's going to give us this money market equilibrium and the interest rate. Okay, so that chart from the beginning of this lecture now makes a lot more sense. Okay, let's do one experiment at least with this double chart. Suppose money supply increases. So in the US, Fed lowers interest rate, money supply increases. In fact, the money market chart is going to tell us exactly this. Money supply increases from M1 to M2. Here's the arrow that shows that. Money demand doesn't change because the output hasn't changed, and people's behavior, that's L, hasn't changed either. So the interest rate has to go down from R1 to R2. To check yourself, always think about it. Increase in money supply is an expansionary monetary policy, which is also the lowering of the interest rate intuitively, right? So initially we were in equilibrium 1 here in the foreign exchange market. As the interest rate went down, we now have exchange rate that is more depreciated. Dollar depreciates. There's now more dollars that we have to pay per €1. So when the interest rate goes down, dollar depreciates. Intuitively, what's going on? As dollar depreciates, people don't want to hold it anymore. As interest rates goes down, people don't want to hold dollar anymore, and so dollar depreciates. All right, I have it backwards in my notes. All right. So we can do the same thing using the formula. When money supply increases, real money balance is money supply over P also has to increase. And so the L as of Y and I, the quantity demanded has to increase. We're not shifting the L curve. It just has to, quantity demanded has to increase. And the only way it can happen, given that Y is the same, is by interest rate going down. Because remember, L is an inverse function of the interest rate. As the interest rate falls and I star stays the same, we know from uncovered interest parity, E has to increase. So expansionary monetary policy, which is an increase in money supply and decline in interest rate, always leads to currency depreciation. So now think about what happens to a foreign country. So when money supply increases in the US, what happens to Europe? Well, for Europe, the US interest rate is I star. It's I from our point of view, and it's I star from their point of view. Nothing else changes. So as I star falls in the UIP chart, in the exchange rate market chart, the UIP line goes down. And so E for them is going to go down, the currency appreciates. So expansionary monetary policy in one country leads to currency appreciation in the other country. And that has to be the case. If there are only two countries, appreciation in one country is depreciation in the other. All right. Okay. So let's talk about two experiments with this model. Okay. In fact, you can think about the second one on your own, and when we talk about it next time. So, in fact, we only have one experiment: decline in the expected future value of the dollar. So, decline in the expected future value of the dollar means we're expecting dollar to depreciate. So we're expecting E to increase, and nothing else has changed. That's the experiment. What we learn here, let's look on the chart. Expected return on foreign currency deposit is going to increase because we're going to get more dollars for each unit of our investment in Europe as we convert money back when dollar depreciates in the future. More dollars for the same amount of euro. So the equilibrium is going to move from 0.1 to 0.2 because expected return on foreign currency deposits is going to go up from blue line to the red line. So what you see is the result of expected future value of expected depreciation of the dollar. The result of that is instant depreciation of the dollar. And there will be no other adjustment. So this is an example of self-fulfilling expectations. If you go around and tell all the markets that you think tomorrow the dollar is going to depreciate, and for some reason you have credibility and people believe you, dollar is going to depreciate today. Okay, so self-fulfilling expectations or self-fulfilling prophecy. This is an example. Okay, What happens in a foreign country? Exactly the opposite. If you're expecting dollar to depreciate, it means people are expecting their currency to appreciate. So they're moving from initial UIP line to a lower one, and their currency appreciates instantly. And it has to be the case, because if dollar depreciates today, it means that other currency has to appreciate today. Okay, so next time we're going to talk about exchange rates and monetary policy, and we talk about small and large economies and intertemporal approach to current account, exchange rate pass-through, monetary policy spillovers, and if we have time, talk about taper tantrum. And so we continue reading chapter 4, and there's another required reading from Brookings' paper, the Rethinking Central Banking reading. And if you want to read some more, there is a great technical but not very complicated paper by Giancarlo Corsetti and Paolo Pezzenti, The Simple Geometry of Transmission and Stabilization in Closed and Open Economies. It's a graduate level classroom material on monetary policy spillovers. And they use those slides to make presentations at different central banks. So these are very, very informative if you can handle equations that are a little bit more sophisticated than what we have in this class. All right, that concludes lecture 6. I see you guys all on Thursday. Bye.